Thanks, Darren. Quite an honor to be the first one to be able to kick that off. How many are we from Sytac? Can I see some hands? Yeah, quite a good presence here. All right, perfect. So everyone's talking about GenAI these days, right? Everyone has generated code, maybe generated text and images, but it's once you start to use it a little bit more professionally or seriously, you quickly find out, okay, there's a lot of stuff that I don't understand that's happening in the back. Why is it hallucinating? Why is it forgetting the things I just told it? There's a lot of details. And once you start building AI applications, it's really important that you do actually understand some of these details. And some of them are unsolvable, but you have to understand what can happen. In this talk, I want to walk you through first some of the basic principles that underpin this development, this technology. Then we'll talk about some of the tools that you can deploy around it to leverage it. And then we'll talk some patterns, behavioral patterns, development patterns, because I presume most are developers. So we'll also talk a little bit about how do you make the AI work for you. So, table of contents. So first we'll talk about landscape. Where are we now? What is happening? Where are we on this curve of increasing speed and adoption and development? Then we'll talk about technology, fundamentals. How does an LLM work? We'll talk about the tools, already mentioned, patterns, and then of course the one we can't get around, agents. Maybe I'm in an AI bubble. I'm probably in an AI bubble, but agents are all the rage these days. And then we also have to talk a little bit about future, because we are at some place in space-time, but we're also going somewhere else very fast. And specifically with this technology, you have to realize where we're going to anticipate and how you have to be in that future. Okay, we're going to go. Okay, and we have to start with why, and kind of spoiled the end already a little bit, but the reason is that I think that it will change all of it almost forever, and there's no way around it, especially if you're in software engineering. Your job is not easily replaceable by AI, but it's definitely impacted by AI. And also for many others here in the audience, if you're in sales, marketing, all of it is closely tied with this technology. So, okay, I'm just gonna stand here because this clicker does not do much. So GenAI will change everything. Then, this is the dot on the horizon, or the moonshot, or whatever analogy you want to use. But this dot is somewhere, this is the future, this is where we're going. The question is, what is that dot? And also, what is the road that leads us here? Some people at OpenAI, they're like, oh, we're going this way. And some people at Anthropic are like, we're going that way. And Google is another way. And they all have different visions of this future. They're all building really fast a lot of things. But nobody knows where that dot eventually will be. However, there are kind of boundaries where we're staying in between. So we are following some general direction. Where is everyone, in a general sense, going? And it's important to kind of understand that. Yeah, so where we're going. Boop. Who recognizes this image?
It's a Shiba Inu.
Yes. But that was not the part that I was asking about. So all of this weird stuff.
Feature map.
Feature map, good guess. Not completely right. Anyone else guess? Close guess. This was in 2015, so almost 10 years ago already. This is called Google Deep Dream, and what they did essentially was AI has a certain bias when it looks at pictures, and they just kept enforcing that bias, and out popped really fundamental features that these vision models have, such as eyes were a really common occurrence in many variations of this model. And so you could tune it, but in this case you see eyes, dog faces kind of popping up everywhere. Who recognizes this picture?
That's from The Shining.
Yeah, what is it?
So this is the winner of one of the contents.
Yeah.
But actually, then the artist says this is AI generated.
Yeah, exactly. Very good. So indeed, this was submitted to the the Sony Photography Award in 2022, and the author, after winning the prize, so he won the prize, and they were like, "Oh, great!" And he was like, "Oh, sorry, I can't take it. This was AI generated." And he said he did it to kind of start a discussion of what is the meaning of AI, how do we relate to it as photographers, and in these competitions, what's the place that it has there? Then, famous tweet is maybe a big word, but this was tweeted by Sam Altman 2 weeks ago. Does anyone, so to quickly describe it, so ChatGPT launched a little over 2 years ago, and it was one of the most viral things, and it got 1 million users in 5 days. Recently, they added 1 million users in 1 hour. What was the event that led up to this user onboarding? Does anyone know?
3 or 4 something release?
Sorry?
The new models?
No.
Which generation?
Yes, it was Generation. The Ghibli one, yeah, exactly.
Guys are too smart.
Does it not play? Can we play? No, okay, we're not playing. Well, we are playing. So this was a video generated by a video generator, I think it's 2 years ago now, of Will Smith eating spaghetti. And then recently this thing went viral, like that's the current state of the art. This video was just actually him making the video and mocking the AI. So no AI yet, but people are asking Sam Altman, please recreate this video so we can understand how good AI actually is right now. But nobody has access to Sora really yet, so still waiting. This is the Google Trends of just the word AI. I think you can kind of pinpoint where ChatGPT came into play here. And this is like at 5 or something, so we've really seen a huge increase. It's not a shocking thing, but I thought it kind of gave some perspective on how things are going. So the landscape, let's move on to how things are. Please, hands up if you've used AI to generate code. Done codes, right? Okay. Well, okay. Not as much as expected. Generate images. More, yeah. Paid for AI tools. Okay. Same people. Used an AI coding assistant.
What's the difference between... Oh, okay.
Well, if you have Claude Desktop or ChatGPT Pro, something like that. I've Ghiblified a photo. Oh. 2. All right. And it's good to talk about Ghiblification of photos for a little bit, because the reaction out of the AI, or just the whole world essentially, was really a huge backlash. Why do you have this? Why is this model able to do this? You're infringing on IP. It shouldn't be doing this. And the founder of Ghibli Studios even called it an insult to life itself, which is quite a strong statement. If you ask ChatGPT to generate a Ghiblified photo right now, it will politely refuse. So they did do some things to make it less easy. So for this presentation, clearly, I had to go to a different model. So I had to ask Flux, which is a different image generation model. But yeah, it's not terrible, but it's definitely not good as well. I'm 20 years older, lost my glasses, and the whole vibe is different. The good thing is that it really is focused on the word Ghibli, this filter. So what I did was ask AI, write me a prompt to create the style Studio Ghibli without mentioning the word Studio Ghibli, and then you get out still a pretty good result from ChatGPT. So this is using ChatGPT.
Yeah, cool.
Don't... A little other poll. I wanted to wonder kind of how you guys are seeing the development of AI. So please raise your hand again if you think your job will change a lot over the next 2 years. Okay. 5 years. Yeah. Still some holdouts. 10 years. Okay. Not much. Oh, okay. What do you do? Yeah.
He's still talking.
So Wired did a little research among some people, oh, this is a little bit large, but 3 out of 4 coders have used AI, and the vast majority use it at least once a week. So that's already quite a number. So 70% use it like all the time. I really like this quote phrasing, because apparently that was in the question like that or something. But yeah, 70%. 1 out of 2 have employers that pay for AI services already, which is, I found that to be a surprisingly high number, at least coming from where I work. And then in terms of how this is used, the majority is using the web interface. But then a surprisingly large part is also using the IDEs or text editor integration, and then a smaller section, the application. And of course, they have a quite big overlap with this and this being the bulk of the users. And I think with developers, you will see definitely a migration from here to here, while the technology is maturing and AI IDEs start to become more pressing. So then, technology. Essentially, an LLM is this. It is just predicting the next word really fast, really well, in different variations. Yeah, that's it. We put in a ton of data, we put in a ton of compute, and they get really good at this. And by steering them a little bit, we can get amazing results. They suddenly become able to summarize, translate. They start to be able to reason. It's quite astounding, and it also dumbfounded a lot of the researchers working on this. To be specific, it doesn't just predict the next word, it gives a probability distribution over all the words that it knows, which are a lot, and it will give something like this. So if you put in the capital of France is, it will say, okay, Paris, super likely, 90%. Dense, 2.4%, diverse, 1.2%. And it will also select the next word by default based on this probability distribution. So there's a 90% chance of it selecting Paris, and there's a 2.4% chance that it will select dense. So that's why you get, if you put in the same prompt twice, you get slight variations or different answers of the same question. And it's actually not looking at words, it's looking at tokens, which are a little piece of a word. In general, each token is about 3/4 of a word. So if we have 400 tokens, we have about 300 words. And these are kind of the building blocks of the language, so it doesn't have to remember each individual variation of a word, and also between languages, those are just chopped into the same blocks. This is very important to know when we talk about things like this. So how many R's does the word strawberry has is a very famous example of where LLMs failed because they don't see letters, they see these tokens. And so before, this is an image I found online because they fixed it currently, but here it was saying there's 2 words or 2 R's in the word strawberry. If you if you force it to have it spell out or explain the answer, it starts to do it letter by letter, and then it typically does make the connection, oh no, it's actually 3. By now, I think it's kind of leaked into the training data, and it will do it right by default. But if you find a different long word with, and you will ask the same question, there's a very high chance that it will fail again. And it all makes sense if we look at how the word strawberry is tokenized. So we have ST and then raw and then berry, and essentially none of these are an R. So yeah, how would it know, right? Just from this. Another thing we have to talk about is the temperature. And if anyone has ever looked at like the AI editor, not editor, but like the AI portals or AI studios, there's always the option temperature. And temperature just means how random essentially is the output. If this is the base probability distribution of the words, the base is with temperature 1, where we don't do anything to the output. If we lower the temperature, it increases the differences between the high and the low predictions, and essentially increases this gap. If we put temperature at 0, we have the highest one is 100%, and the rest is all 0.
It's more deterministic then.
Yes, it will be more deterministic. So for critical environments, that is typically a recommended setting to put very low. If we increase the temperature, that's where you get models like with Copilot, you had a creative mode, or many other models also have creative modes. That's where you increase the temperature a little bit to get more random output. Yeah. Then I think the last one that we need to talk about is context window, which means how many words can you put into the model before it doesn't see it anymore. ChatGPT 3.5 or GPT 3.5, which was the model used in ChatGPT 3, could do 4,000 tokens. So let's say 3,000 words, give or take 9 pages. Currently we have Gemini 1.5 is the largest commercially available model. That one has 2 million. And this is true to life. I put 4,400 of these things in Excalidraw, which is a good benchmark of how fast Excalidraw is. But this is a comparison of how much stuff you can put in here. If we put that on a graph, that's an increase of 3,800 times in just 6 years. What is it? 6 years? Yeah. So that's really fast. And now we won't be able to keep up this level of increase, most likely, but still. The 2 million is also about 3.5 Lord of the Rings, like the full trilogy. So that's quite a lot of text you can put in there. You can put in full movies. You can put in, I don't know, audio books, whatever. You can put in a lot of stuff at the same time and ask questions about it. Yeah, I think that's what I wanted to say. Then when we come to LLMs are available in a very wide variety, and it's essentially like picking your Pokemon. Depending on the opponent that you have or the use case, there are different models that suit that use case better or worse. And LLMs have a lot of characteristics. We'll go through them quickly. So input and output modalities is very important. So text, image. Some of them also are doing audio, and specifically real-time voice is a big one that's kind of slammed on top of the LLMs, but still. For the output, we have the same, although no audio. I don't think there's an LLM that, well, some of them generate music. Okay, well, maybe also audio, but very important for your use case. What do we need to get in and what do we need to get out? Multilingual capabilities. Some models are not trained on all languages. Some of them will perform better or worse based on the training data. A good example here is DeepSeek, which came from a Chinese research lab, where they trained on a lot more Chinese data, and lo and behold, it was way better on Chinese problems. So yeah, maybe we are lucky. I don't know. In the Netherlands, I don't know where we are, but most of them have some Dutch capabilities, but it could be a important detail.
WhatsApp don't know Dutch.
Sorry?
WhatsApp don't know Dutch.
WhatsApp doesn't? Yeah, so exactly. So for some it will be there, for some it won't. Technical features. So reasoning is really important with the recent development of reasoning models. We'll get later into what that means. Tool calling, so is it able to, if you give it a list of tools, like these are API calls you can make, that it knows how to interact with that. And structured output also, if you're working in an automated environment, it's really important that you get output in a structure that you expect. Otherwise, yeah, you have nothing. Practical factors, so maximum context window size, we just saw what that means. If you want to have a lot of context window, or if it's too large at ChatGPT, you can switch to Gemini, which is the largest. If you have ChatGPT, you don't have anywhere to go, essentially. Price per token, so there's different pricing tiers of LLMs. What is your budget? How fast? Oh yeah, no, okay, that's the next one. Price per token. You've different pricing tiers. Reasoning models are more expensive than non-reasoning models in general. So consider that. Are we going on standby? Good. And the last one is response generation speed. So how many tokens can it spit out in a second? And of course, smaller models do this faster than larger models. But for some, it's fine. Like if you need to parse a document into JSON, you don't need that large of a model, and this is way cheaper and way faster to use a smaller model. if we look at some of the well-known models, we can go through some of the characteristics that they have so you get some perspective on where they kind of fall. So we'll start on the left with Claude, which is generally considered the best for coding. The input modalities are not that large, just text and image. It's known for coding and now also reasoning with the 3.7 release. The context window is 200K, and it does support a lot of the requirements that I just mentioned, like function calling, structured output, reasoning. It also has computer use if you have the Pro version, where it can operate the computer that it is running on, which is a little bit gimmicky, but it can be used for some things. Strengths, it's a good coder. It has content caching, which is really important when you are coding, because typically you are putting the whole code base to Claude, then with a question, you get it back, and you put the whole thing back and forth every time. With the caching, you don't have to pay for all the tokens it already saw, and it will save you a lot of money. Weakness, no image output, no direct voice, so can be good for some cases, not so good in others. Gemini 2.0 Flash, this is the middle-tiered model from Google. It is very fast and efficient, and it has a huge context window, which is nice. So it's 5 times more tokens than Claude. It can output and input way more dimensions. So for example, for user interviews, I was uploading videos and recordings, having it transcribed and translate and summarize, and then answer the questions that I wanted to actually have as part of an interview. Super powerful for that. It doesn't have reasoning, at least currently. There's an experimental model, but that's something else. It supports function calling and structured outputs. So for many programming related things, this is one of my favorites. It's very fast, very cost effective. Can put in a lot of context. Not reasoning, so it can make mistakes. Please, what is happening?
It's finally time for caffeine or keep me awake application.
Yeah.
On the computer.
Yeah. And then last one, DeepSeek, because it was such a name maker when it was released. So this is the open source version, and that's also something you have to consider. The LLM providers built a lot of stuff around LLMs to make them more powerful, to increase their specific capabilities. So for example, you can put images into DeepSeek on the API, but not on the open source version. On the API, if you ask about Taiwan, it will tell you, I can't answer about this topic, but if you ask it to the open source one, it's perfectly fine. So there's all these details in terms of censorship capabilities that can change. So function calling in the open source version, not really supported. Structured output, some people said they were able to hack around, but if you want to have reliable output, maybe that's not the way you want to go. It's quite good at reasoning. It's exceptional at coding and math. Chinese is a specific one where it's really outperforming competition. But the good thing is it is open source, so you're able to run it on your laptop, or if you have a GPU, you can run it at home, which is not possible with the other two. For some LLM providers, this information is very clearly available on the website. So this is from OpenAI's O3 model, where you can see, okay, it's only supporting text, chat completions. These are terms of supported endpoints, and then also features that we just mentioned. It's good to have this overview before you pick an LLM, but not every provider has a comprehensive overview like this. So sometimes you need to ask an LLM, what can you do, and get an answer. Because it's really important which one you pick. But it's also easy to switch mostly, at least within the same provider. Reasoning models. So we have to talk about this because they really make a big change of where we came from in terms of the complexity of problems that LLMs can solve, and also the paradigm, because up until last year they were like, okay, we're gonna scale training data and training compute to the moon, right? And then some people were like, okay, hold on, maybe we need to also, when we are predicting and doing actual answering of questions, give the LLM time to think. And this is what we call test time compute versus train time compute. And that's where these reasoning models came in. So what does it mean for a model to think before it answers? And it's actually really simple because they train an LLM to have, between these tags, stuff that it doesn't give to the user. Or sometimes it does, but with OpenAI it doesn't show it to the user. With DeepSeek you can see it. In that window, the LLM has the ability to reason about what it did before. It knows it doesn't have to be the final answer. So if you encourage an LLM to, research different variations, different options in that window to reflect which one was the best option and then present finally that answer to the user, that makes a really big difference. So in this example, if the query is what's 42 times 3, you can see the LLM, okay, this is the answer. Oh, but what if this is a reference to the Hitchhiker's Guide to the Galaxy? Should I make a joke? No, let's just give the answer. And so it decides against that and just gives you the boring answer. But it's interesting that those things can happen. And if you look at some the thoughts of some of these models, it's very funny to see what they're looking at and how they're thinking about your problem. There was actually one paper where they wanted to control how long the model was thinking. So what they would do is if the model wanted to finish the thought, they would just replace that with a wait, but, and then let the model finish the thought after that. And they would do that until the model had thought as long as they wanted it to be. So yeah, it's easy to control and it really makes a very big difference. And in terms of how big that difference is, so these were the benchmarks that OpenAI dropped with O1, which was the first model, and specifically with things like math and coding, we really went from 13 till 56 and then 83 on the final release, and from 11 to 62 and 89 on the coding side. So that's a huge increase. Where before people were like, oh, 11, we're never going to break through that barrier. They're just not going to be that good at it. And then they did this, and DeepSeek came, and Gemini had their model, and Claude had their thinking model, and now they're all at this level if you have the the buck to pay for it. Okay, tools. Okay, we're half an hour. Okay, that's good. We're on schedule. So there's a little bit of warning of drowning here. I work with this every day, and there is so much. Every day there's a new framework. It's a little bit like JavaScript in that sense. There's a lot happening. So bear with me, I try to explain it. Some of the lists, you only need to remember the first one if you really just want to remember, okay, where do I start? But I do want to give kind of a grand overview of these are the domains, and these are the tools within that domain. So we'll start with this, which is the GenAI stack. And I felt the need to start with this because typically when we as developers need to make decisions, it only influences this area, maybe sometimes this, but if your company is on Azure, this one is also fairly fixed typically. So we kind of stay in here. With LLMs, if you say, we don't want to use an API, we want to self-host a model, suddenly you're in this and you need a bunch of GPUs, and that involves a lot of differences again in this that are added on top of the changes that you already were making there. So it can be complex really fast. That being said, let's start with some visual AI frameworks. And these are really easy because it's kind of drag and drop. You still have to configure, okay, I want to use OpenAI and this model, and you put in your API key. But that's really the extent almost that it goes. And so you can see here an example of an agent to input a user form and put it onto Slack. And this one here, it's visualized really cleanly, right? We have some memory, we have a model that we're using, some authentication with Entra, Jira integration, and it's going output to Slack. Beautiful. Why would you need anything else? Well, there are some cases where you do need other stuff. You already see here the the tools. So the memory in the chat model is typically just one. The tools can be a billion things. You can basically put anything in there. So to give a bit of inspiration as to what that can be, I just put a bunch on this slide because I also forget sometimes how many options you have. But all of these can be put into an LLM in some form or shape, altering the capabilities of that LLM, interacting with different systems, creating different things. So if your LLM doesn't support images, okay, maybe we can add image generation. Is that the one? Yeah, I think so. Image generation. So that way you can also add modalities on top of the LLMs it didn't have previously using these tools. So now we're going one level deeper, which is programmatic AI frameworks. And these ones are, yeah, if you're working in Python or in LangChain's option, also with JavaScript, it really allows you to go deep into the weeds. These, I would say, are the four most popular ones. There's many more, but this is an initial outline. So if you are wondering where do I need to start, pick one of these. Honestly, they do roughly the same, at least these three. And then this one has a slightly different approach. But in the end, mostly, they're not that different. So pick one, stick with one.
Why there is a red flag on the web?
Oh yeah, that's an excellent question. Almost forgot. So LangChain, yeah, it's just shit. That's basically the reason. They have a lot of good stuff, fundamental stuff, and then they have a lot of stuff that is totally unnecessary and so confusing. So if you are starting out, I would say, and you need all the options available to you, pick this one or this one. If you just need very simple output validation of LLMs, this one is the simplest. And LangChain has the most options, but it has so much stuff built in that you don't know where to look. So keep that in mind. But if you're working in another language that's not Python, then you don't really have a choice. So I think LangChain is the one that has the most support. And LangChain also has a whole ecosystem around it in terms of monitoring, guardrails, security. So yeah, you are locked into that ecosystem with the rest, which is nice because they give you a lot of tooling that you don't otherwise may have. And this slide kind of shows the components that each of these frameworks have and how you can combine them to solve different problems. So an agent, in this case, storage and indexing, where you may just want to find different documents, or extraction, where you're asking questions about some document. So some of these you can already do in terms of you just upload the document to ChatGPT, but all of that context you don't have available when you're using the API version, and then suddenly you are the one responsible to build that, to build PDF ingestion, to build video ingestion. All that stuff doesn't come out of the box. Next one is self-hosting options, and this is, I would say, mainly relevant for when you're trying to experiment and you need to run something on your laptop locally. But if you want to have something hosted on a GPU cluster that you have available because, I don't know, you're academic or small company that has some GPUs, this also goes for that. Ollama is the easiest one. With the icons, I've indicated that these are CLI based, and LM Studio is also visually. There's a couple others as well, but I would say this is the basis. If you want to do anything in production, try to use VLLM. For local, I think Ollama is the easiest. You can run or download and run a model with literally one line of code, and then you can either chat in the CLI or connect it to other tools. So the frameworks we looked at before this, they all have integration to Ollama. With VLLM, it's just hosted on an API endpoint, and you can connect there. Development tools. This is a big one, of course, because I think most people here have tried one of these. So GitHub Copilot and VS Code. You have some other ones where you can plug in your own models like Klein, and a new one that's RuCode, which is based on Klein. For the IDEs, Cursor and Windsurf, I think, are the most famous names. Who here is paying for Cursor or Windsurf? Yeah, okay, that's pretty good. Yeah, 6. Huh?
Windsurf, can I elaborate? Windsurf is probably in the past known as Cadeo, and I was using it for a while, and everybody was saying me it's a piece of garbage, use something else like Copilot, and now everybody uses Cadeo as a Windsurf. They're like, ooh, it's so cool. Okay.
Did they make any good changes or just a rebrand?
Just to rebrand. In Visual Code, we named it Windsurf.
Okay. Well, maybe that's sometimes all it needs. Yeah.
Quick insight on Windsurf, OpenAI is considering to buy them.
Yeah.
Oh, really?
Yeah.
Okay. Exciting. Yeah. Is that a good thing or a bad thing? Then, yeah. If you work on the CLI, Aider is really big, and now Anthropic has released Claude Coder, which just work on the CLI. You give it a prompt, and it will do it there. I am a little confused why you would want to use this if you have the IDE integrations available, because for me, this just does the same as those, but in a worse visual environment. But I don't know, maybe I'm biased against CLI. And then the last one is Firebase Studio, and this actually released like 3 days ago. A very exciting cloud-based IDE from Google, where it's really a non-coder first environment, where you get this development plan, like as text, this is what I'm gonna do, this is the design elements that I'm gonna use, very well made, and then it will start to code, presumably fail at some point, and then you can switch to the IDE version to actually fix it and kind of finish up the application. No, that's the wrong one. Okay. The biggest challenge right now, I think, is specificity. If you don't give it very clear, very precise instructions, it will do something else than what you intended. So if you don't break down your task, it will fail. If you are ambiguous in your requirements or you don't specify something, you leave it out completely, then it will also just start to do something. I thought this quote was nice: the quality of your output is directly proportional to the specificity of your input. And I think this brings me to the patterns, because there are ways to interact with this and to improve the understanding of the LLM of what it is that you want. So these are prompting techniques. Some of you may know. I am not really going to elaborate on what they are, but look them up if you have this issue where the LLM is not really doing what you want it to do. But few-shot, okay, I will shortly elaborate. So few-shot prompting, where you can put in a couple of examples, example input, example output, to have it understand where it needs to go. Chain of thought is you're essentially just asking it go through it step by step. It's really not that hard. Tree of thought is a little bit more complex, where you want to have it create different versions and then kind of combine the best parts of that. Self-consistency, and then there's dozens of these, but yeah, just be aware that there's prompting techniques to improve getting the thing that you want out of an LLM. This is also my big tip: use LLMs to prompt LLMs. So whenever I need something specific from an LLM, I first ask it to make me a prompt that makes that thing very specific. So I want to code this feature, okay? Then it will give me, a paragraph explaining exactly what it wants. Then I'm reading that, and I'm like, oh, okay, this needs to change a little bit. I need to update this a little bit. And then it's good to go. And then I have it execute that actual tasks. This is really good because LLMs are really good prompters, unsurprisingly. In terms of development patterns, there's two big ones. So one is greenfield development, starting a new project, and essentially it would be ideal if the LLM did all the work, right? You can write the requirements, the plan, and then you don't want to look at it anymore. Call me when the thing is finished. But there's still some steps that you need to take to really get to the end result that you want. So one is idea honing, which is kind of refine the idea. You can do this with an LLM, where you have the LLM take on the role of a product manager or some other role where you can spar with about the idea. Task decomposition is very important, where you can essentially what are the requirements of my MVP? And again, LLMs are really good at this. So you can have the LLM output kind of all these requirements: security, functional, non-functional. And once you have that list, you can go one level deeper. What are the subtasks of this? And there's some software later on that I will show that do this really well. And then you have implementation. Implementation typically needs to be balanced with the tests. Have it do one feature, write tests, run the tests. If it's good, continue with the next one. If you skip this, it will do the feature and do 50 other features, and then none of them will work typically. So very important to do that. And that's also where the incremental iteration comes in with existing code bases. Take a user story or whatever, have it decode that into several tasks, and then again, add the testing after each step. And that way you can get pretty good results. Not perfect, but pretty good. So the task management and the task decomposition, these are some tools you can use for that. So Taskmaster AI is really nice because you can give it kind of this general outline, like the requirements list, and it will make a very detailed list of steps that it needs to take to get there. For a human, too detailed sometimes, but for LLMs it's really useful. Cursor rules are things you can put into Cursor that it will consider for each request. So there you can also say, okay, decompose task, put them in this file. If you finish the task, update that file. So have it behave in a certain way within the IDE. And it's not, it's a functionality that comes out of the box, but the prompts are obviously not in there, so you have to put them in there yourself. And then Rue Code, we already saw it in the VS Code integrations, but it's essentially Klein, which is just an LLM plugin in VS Code. But this one is really based to host different agents, is maybe the personas in the IDE, so you can spar with an architect, with a senior software developer, with a product owner, and kind of shed different lights on the problem that you're trying to solve. I have not used that one myself, but from what I saw, it looked very interesting. For the last, or not the last, another consideration you need is costs, because everyone likes money, so it's important to keep track of this. So one is caching. I already mentioned it with Claude, but some of the LLMs support caching, and that reduces cost a lot if you're doing iterative calls with the same information in there. Some of them don't, and then it doesn't matter, but for your use case, consider this. Batching is important, so almost any API supports, okay, here's 20 things that I need to have translated or whatever, rather than one. And they will typically decrease your cost per token significantly, 50% or sometimes even more. And the last one is keep track of your token usage. So all of the APIs will tell you this is how much tokens this was and how much it cost you. The cost typically not so much, you have to do that yourself. But track these things, put them in a database, understand how much you are querying. Some of them also become more expensive after a certain threshold. So the first, for Gemini for example, the first 128,000 tokens is one price, and then after that it becomes more computationally expensive and they increase the price. So also something to consider. MCP, who has heard of MCP? Okay, pretty good, not too bad. MCP was very hypey recently, so we're now in this part and it's already much higher. But the world discovered this open protocol that Anthropic introduced. And it is basically an open protocol that enables seamless integration between LLM applications and external data sources and tools, meaning it's essentially a REST endpoint or a REST interface on top of anything that you can build. And you only have to build it once to integrate it with any LLMs. Really big change in how we were doing things. Very shortly, you built an MCP server, i.e. a REST server on top of some source, some tool, database, a file system, doesn't matter. And then we have an AI client that has an AI application that has an MCP client that can connect to this thing. And this thing is general, you only have to implement it once, and this you also have to implement only once for each of these services. So that really reduces cost a lot. Agents. And an agent, we define it by this. Something that can autonomously make decisions and take actions to achieve a goal. And I found this beautiful image of an AI agent online, which is horrible the longer you look at it. So yeah, please enjoy that. Agents are essentially this robot or an AI that interacts with an environment. The environment gives something back and the AI does something more until it's finished and it will give the result back to you or to someone else. And it is made up of these components, which are very essential for AI agents because generally they're doing several or multi-step tasks which increase complexity. We require reflection, planning, tools, and collaboration. And specifically, these three are really improved by using reasoning models. So the upcoming of AI agents and the upcoming of reasoning models is not just a coincidence. The simplest form of an AI agent is this, where we have the agent and we give it some tools and it can do something with those tools. If we go a bit more complex, we can also have this, which is the hierarchical multi-agent, where we have a manager, essentially, that has different people to their disposal that may have access to different tools as well. So this could be an HR specialist and a technical person and, I don't know, something else that are all living together in this team. But you can also have a more bilateral or group chat situation where everyone's chatting with everyone. You can make this as complex as you want. Any type of organization is allowed. So yeah, whatever fits your use case, but these are I would say the three simplest ones. In terms of frameworks, also a lot popping up recently. LangGraph is the ecosystem of LangChain. It's connecting there. Yeah, no red flag here. No, I still hate it, but it's not a red flag. Crew AI is a very popular open source one. AutoGen is made by Microsoft. Agents SDK is made by OpenAI, and Agent Development Kit is released by Google. And this was actually really recent. This was like 1 week ago or something. So very new. They all kind of do the same thing. They try to orchestrate multi-agent interactions and clarify or make it easier for you to structure how things are controlled. There's no right or wrong here, just depending on the use case that you want. There is a flowchart for when you need an agent, because an agent is the most advanced step, I would say, where you give autonomy to an AI system, and not all or most problems don't need that, right? So is the task repetitive and time consuming? Yes. Okay, well that's good. Does it require structured data? No. Okay, then you can just have an LLM prompt. You don't need an agent. Is 90% accuracy acceptable? Where's this going? Is this the no? No, if it needs human oversight is required. An agent which is generally doing things autonomous might be a good option, but probably maybe not. And success criteria are also very important, because you need to understand how is the model or how is the agent doing, and how is it doing compared to a human agent as well. Okay, then lastly, we have to talk about the future. And that means we have to talk about exponential growth. And who wants to take a gander at what this plot means? What it is representing?
Evolution.
Yeah, evolution of what?
AI.
AI.
Global AI is not general.
A little bit. It is representing the total compute in a computer that we have. And you can really see that a lot of time nothing happened, and then very recently it really started to skyrocket. And grasping exponential growth is really hard for humans, because it means that for the majority of time nothing is happening, and then suddenly you're in the sky. We also see that here with the with AI models being developed, and it's important here to see that this is a log scale. So each step is a 100-fold increase. So 100, 100, 100. And here, this is kind of the point where deep learning took off and we started to have computer vision and NLP. And we're now all the way at Gemini 1 Ultra and a little beyond. But this is a 4x per year. That is a really significant number. And we don't really see a huge slowdown of that yet. Most companies are building way more data centers and way more compute. Funny thing is we also see it here, but a little bit differently, which is the train time compute that we put into a model versus the test time compute that we give to a model and how it performs on a certain benchmark. So we see here that if we increase train time compute, and this is also on a log scale, so this is like, I don't know, 1,000,000 times more than this, we see it increase, but we don't see it increase, and we don't see it increase linearly, and we see it kind of folds off at the end. With test time compute, which is where we give it more time to think, we just have a straight line. But it's not ideal that this is 1,000,000 times more because we cannot keep doing this a lot of times, right? There's a hard limit in time and money that we want to have this. So for these benchmarks, typically they also have not, did your model solve the problem? They did how much compute and time did the model spend to solve this problem? This one I really enjoyed, which shows how long a task an LLM can do that was previously done by a human and how it's improving over time. So we are now at the point where models can generally cover 1 hour of work. And in terms of computer or text jobs, so we can answer a question, count words, find fact on the web, and now we're at training a classifier, which is like a data scientist's job. And again here, on a normal scale, it is this, but if it's on a log scale, it is that straight line again. But here we also expect to see exponential growth, where it might do 4 hours of work or a day of work very soon. And so this is based on 50% success rate, so just finishing the job correctly. This was something said recently by the old chief researcher of OpenAI, Ilya Sutskever. The more it reasons, the more unpredictable it becomes. And this is a consequence of us not understanding the intelligence anymore, or essentially the limitations of our own intelligence. So we saw this with the famous move 37 in the AlphaGo match, where the AlphaGo beat Lee Sedol, the Go master, and it made a move that no human player would have ever made. It was so weird, but it was a really good move, and now it's really broken into the field, but nobody would have predicted that something like that would happen. And we will see this becoming a real problem once we start to get near superintelligence or general artificial intelligence, where we stop losing we start losing an understanding of what the model is doing. Okay, almost done. This is the machine learning, AI and data science overview of 2024. There are now 2,000 logos on this thing, which is just very dumb. And this is an increase of 600 compared to last year, and 10x compared to 2012, I think, when they started out. So, I don't know, I think this is also an example of some form of exponential scale. So in 3 years, we will have 50,000 logos on this overview, most likely. And that brings us to the end. So I hope you guys didn't drown too much. The takeaway I want to give with this is so much is happening. Every day brings a new model, a new framework, a new thing to discover, research, and read about. And it doesn't matter for whatever you're building. So pick a couple components, stick with them. LangChain is not going to be worse tomorrow than it is today. It might be, who knows. Yeah, stick to the basics, pick the things, and go deep into that. Oh, DeepSeek, yeah. Yeah, there's so much more: monitoring, evaluation, debugging, guardrails, AGI, whatever. We didn't talk about it, which is good because this is already going way over time. So thank you. Link up with me at LinkedIn, although I think many of you already have. Interesting to hear about your GenAI challenges if you're thinking about a problem or use case or whatever, your personal hobby thing, and discuss implementation strategies. And that brings us to